and we're always happy to have Pivot 3 on our events. And we are joined today by Dan Deppen, who is the Senior Product Manager for Pivot 3. Dan, thank you for joining us today.
All right, thank you.
And it's your show. Take it away.
All right, thanks a lot. So yeah, my name is Dan Deppen, Senior Product Manager here at Pivot 3. And today I'm going to talk about Pivot 3's hyper-converged infrastructure, and then also our hybrid cloud and multi-cloud strategy, and talk about some of the new announcements we just had here very recently. So some of you may or may not be familiar with us at Pivot 3 already, but we've been around the market for a long time. Founded back in 2006, released the first hyper-converged product back, I believe, in 2008, actually before the term hyper-converged was even invented. We had that architecture. We've got about 2,500 customers worldwide in many different countries around all the geos, 18,000 plus systems installed. So we've got a very wide install base, a lot of experience deploying HCI, and a lot of different users and various use cases and enterprises that we're in. So very large market presence and depth of experience with hyper-converged. There's several key pieces of technology that we're known for. Part of that is our patented erasure coding, our NVMe flash, data path, and our policy-based management. So I'll go into some more detail on that and then talk about how we're extending that to hybrid cloud. So first, some background on hyper-converged and what that is. So hyper-converged has really transformed the way that IT gets delivered today. So if we look at a traditional infrastructure and how it was done, typically you've got separate areas of network, storage, and compute. And these often come from different vendors. They require tuning and configuration to get them to work well together and to get the right performance that you need. So certainly not fast or easy to deploy. So when we get to hyper-converged, what we're really talking about is delivering networking, storage, and compute combined together into single nodes, and so that you really have a flexible deployment model. And I kind of think of these hyper-converged nodes as Lego bricks. So they're very simple to deploy and very flexible, and then if I need to scale, I just add more as I go. So you get away from this old model of what I think of as almost like American choppers, where you have to cobble together something to get the performance that you need. But as we move forward, especially in the world of cloud, HCI has to be able to do a lot more. So if you look at some of the traditional HCI architectures that are out there, they tend to be targeted or designed for very targeted applications. So you have the flexibility and the simplicity, but you get some drawbacks with that. As we move forward to be able to enable hybrid cloud, what HCI really needs to be able to do first is handle mixed workload environments. So we need not just higher performance than we've had with other HCI systems. We've also got to be able to have predictable performance to hit SLAs on a per workload basis, and then also maintain all that flexibility and simplicity that we get with HCI. Build this out. So if we look at those conventional HCI architectures on the left, that tend to be designed for targeted applications, typically these are deployed in silos to go in there and solve a very specific problem. And with these architectures, generally the resources that each application has available to it are going to be limited to the storage and compute capability within that node. Over on the right at Pivot 3, what we've developed is a distributed scale-out architecture, and this enables an application running on one node to potentially utilize all the resources of the entire array. So the capacity, the IOPS, the bandwidth are aggregated, and then this allows your virtual machines to have access to potentially all the resources or a subset of the resources depending on the SLA. So on the left, for example, the performance you can get out of one application might be limited by the number of drive spindles that you have on that one node, whereas what we do at Pivot 3, by actually sharing the resources of the array, you might have an application running on one node, but you might be able to use all the drive spindles from the entire array. So you have a lot more ability not just to get high performance, but a lot of flexibility in how you can set up your system. So what we're doing as well is making wide use of leveraging NVMe PCI flash for the highest performance. And then we have multiple tiers of storage that can include SSD or HDD. And then our software is intelligent enough to automate the placement of that data on a per workload basis to make sure that all of your SLAs are met. And what this really does is not only gives you high performance, but enables broad workload consolidation, where you can have multiple applications running on the same system, maybe each of them with different SLAs, but guaranteeing that each of them are getting the resources that they need. So we've also developed a lot of very intelligent algorithms to make this possible and allow all of these workloads to coexist within the same system. So the first is our automated data placement. And what we do is we move data in real time between storage tiers based on usage patterns, and then we give priority to caching and to the NVMe flash. So what this means is what the system's doing, it is keeping as much data as possible that's likely to be accessed on the NVMe layer, and then it's tiering back to SSD or HDD as is required. And then what the admin can do is select from some simple policies for each workload and then define performance targets for each of those workloads in terms of IOPS, throughput, and response time. And then we've also got automated service levels. And so with this, you can use a few clicks and you can define which applications are mission critical, which ones are business critical, and which ones are non-critical. And then this tells the system how to allocate the performance. And then the system uses its intelligence engine to put data on the right layer at the right time. And then we've got our policy-based data protection. And so in addition to defining service levels for the workload itself and the performance you need for the workload, you can also define service levels for the data protection policies. So this is going to define order of priority for data protection jobs, and you can also integrate that with certain applications. And so this overall level of intelligence is what enables the HCI solution to expand from something that once upon a time was simple and flexible but meant for a single workload to now one that maintains the simplicity and flexibility but can handle a wide range of workloads simultaneously. And so here's an example of how this intelligence engine can be put to work in a real-life situation. So in this example, we've got three simple workloads with different priorities. And on the left, we have a traditional HCI system where there's no prioritization of resources. So here we've got our order database, which is high priority, and then we've got this dev database, which is lower priority. And so with no ability to manage policies between these and handle SLAs, if you have a spike in the demand for resources in your lower priority dev database, that could potentially create contention with your high priority database and prevent your mission critical application from getting all the resources that it needs. So if we have the same scenario with Pivot 3, so what we'll do is up front define what's mission critical, what's business critical, what's non-critical, and from there, the system automatically handles the allocation of resources. So now, when we have a spike in demand for a development database or for a non-critical application, what it does first is it ensures that your mission-critical SLAs are met, that it's getting all the resources that it needs, and then it gives as many resources as possible to the non-critical resource. So we're not just throttling low priority applications. Those low priority applications can get all the resources that are available from the system, but it's making sure that your mission critical and your high priority resources are getting met first before it does that. So it's nice because whereas a throttle or a cap always limits the performance of that low priority application, now it can still take advantage of the performance of the box. We're just making sure that we don't starve anything that's mission critical. So that's all great, but what do we need to do as we move into this hybrid cloud and multi-cloud world? And a lot more is obviously going to be required. So the first thing we need is more automation around how the system makes decisions. And so that decision engine needs to relate not just to the placement of data on a particular tier, but actually the location of workloads as well. Do those workloads need to be in an on-premise environment? Do they need to be in a cloud, or do they need to be in a particular public cloud to get the best optimization of cost versus performance? And then we're going to need machine learning to constantly optimize these systems. So one of the things we see a lot at Pivot3, particularly in the security industry, is where we have customers that look at the workloads they're running. They have an increasing number of endpoints, an increasing number of applications. So, for example, in the security world, many of our customers will be running some video surveillance software that might have thousands of cameras connected to it. In addition to that, they might have fire suppression software. They might have access control software that's controlling hundreds and hundreds of doors. And as we've seen these trends just over the last 10 years, you see the number of the types of workloads and applications, the number of endpoints are growing exponentially. So if you follow the trends and you look at where these things are going over time, you're going to reach a point pretty quickly where managing the SLAs for each of those workloads and making sure that all of your compliance requirements get met and all of your performance requirements get met become basically impossible to manage on a manual basis. So at some point, the system needs to understand your broad objectives and then automatically implement and automatically optimize itself for what it is that's really important to your business needs. And then, lastly, we have that automation of data and application mobility. So as the system is continuously optimizing and it's understanding what the best location for each workload is, you need to be able to actually move that workload as well, not just have the ability to do it, but actually do it in an automated fashion. So it's an expansion of the intelligence and automation that we do today. And that leads us to the Pivot3 Intelligent Hybrid Cloud, which is what we believe is going to be required to solve a lot of these problems. So the first thing you need is a good private cloud to be able to handle the multiple workloads and then also be able to leverage legacy infrastructure for storage and for other things. So as we move to the world of hybrid cloud, we can't start over and forklift upgrade all of our infrastructure. We need to be able to play with a lot of the existing hardware that we already have. And then the intelligence engine's got to be expanded to be able to interpret the policies and then make automated decisions based on analytics and then automatically orchestrate and deploy a lot of those resources. And then it's also got to be able to work with multiple public clouds to ensure that your costs are always optimized and eliminate silos because, as again I mentioned on the last slide, managing these things manually is not really going to be an option in the future, and for a lot of customers, it's really not that much of an option today. So now I'm going to talk about some of the use cases that we're focused on in Pivot3 over the near term. And this is obviously not an exhaustive list of the hybrid cloud use cases that are of high importance, but these are some of the ones that we're focusing on first. And these are really based on what we're hearing from our customers and some of the things that they want to go and are ready to deploy today. So the first one is backup and disaster recovery, which is obviously one of the key use cases for public cloud. And what this capability does is it leverages the existing Pivot 3 data protection policy management and scheduling capability, and then extends that to the public cloud. And I'll have a lot more detail on that coming up here in a moment. And then the second one is workload mobility, which really consists of two parts. So the first part is the analytics and the ability to scan a hyperconverged system, identify all of the workloads, characterize the performance requirements for each one, and then determine the ideal location for that workload. Maybe the ideal location is where that workload resides now. Maybe it makes sense to move it to a particular public cloud or from a cloud back to on-prem. And then the next step is to actually go ahead and move that application along with all of its associated components and data. So when we're talking about workload mobility, this is really a large step beyond just moving data from one location to another. And then finally, we've got archive, which is answering the need to optimize the cost of storage by moving cold data periodically to the cloud. And so we'll have storage volumes that span from on-premise data centers to the cloud, so that when we archive, we can't afford to take data offline, like you may have, say, with a, with an offsite tape backup or something like that. We need to maintain the availability of the data to all of the applications so that everything remains online, perhaps with some higher latency, but always on and always available. And then, so going into some detail now on cloud backup and disaster recovery. So we recently announced on March 27th, Pivot 3 Cloud Edition for AWS. And this is really a big milestone because this is the first version of our Acuity software that's living and running in the cloud. And what it does is it leverages our snapshot and our replication technology and now extends that to be able to use AWS as a backup target. And it's also the first version of Acuity that's not running in a native VMware environment. So this is actually a full version of Acuity running in the cloud. It's not, a connector or some small piece of software that developed it. It is the real Acuity, and it's the beginning of the bridge, to be running hyperconverged software, not just on an appliance, but on the cloud or anywhere that you want. So, one of the use cases that we see potentially being popular for this version of it would be using AWS as a central repository to keep a golden image of your data and files. So you can use that as a central storage point. So you might have multiple data centers or multiple remote sites. You could also use it as a golden copy. So if you needed to send that data back to, say, a new data center, you've got this nice central point of control. And now these next couple slides, I'll give you a little bit of detail on how this works. So the first thing you need to do is set up your account within AWS and install Pivot 3 Cloud Edition on AWS. But once you've got that initial configuration complete, all of the management and all the monitoring is handled from the Pivot 3 management console. So you've got a central point of control for all of your resources. And then you'll have a Pivot 3 on-premise system can then connect to the Pivot 3 software running in AWS, and now you can use that as a target for your replication. And then it's also leveraging all of the data protection QoS and all the data placement technology that we've always had in the product. So from a user interface standpoint, you're using all of the same interface that we've already had in Acuity. So if you're already familiar with running a replication today, you basically have AWS as an additional option for a target, but you're doing all of that within the existing management interface. So you'll set the prioritization of all of your jobs and set your service levels. You can set your scheduling as needed. And everything else, all of our data protection QoS applies to the cloud as well. So the way you would set this up is you have to set up your account in AWS. You'll go and pull the IP address of your cloud target. And then within the Pivot 3 interface, you just enter that IP address, and it's just another replication target. So you may have replication targets in AWS. You may have second data centers running other Pivot 3 installations there as well. And then you'll create your cloud replication policy, so you can pick from some of the standard policies that we have or create your own. You'll choose AWS as a cloud target. And then you've also got the ability to do advanced scheduling. So, for example, particularly with cloud replication, you may want to configure your policy so that your cloud replication is always running at night or on the weekends, so you're not using up bandwidth that maybe you use during the workday. So you've got a lot of fidelity over how you can arrange them. We have a number of out-of-the-box policies that are simple. You just go in there and click, and it sets a data protection policy. But then if you need to, you can tailor it to meet your own needs. And then once it's done, this is just a screenshot of it showing the successful replication to the cloud. So it's all very easy, and all can be done within the Pivot 3 user interface. As we go forward and build out our intelligent hybrid cloud, that's one of the things that's very important to us, is having a central user interface that's tightly integrated with all the clouds. I think one of the things we don't want customers to have to do is have a variety of different user faces and different clouds, and they have data and applications sprawling in different locations. We want to help customers get their arms around that and make it easier to manage these increasingly complex and diverse environments. And then this is our use case for cloud for archiving, which will come out in the next version of the Pivot 3 Cloud Edition. And what this is doing is creating a storage volume that spans between the on-premises storage and AWS. And from there, we can use all of our policy-based data control, and intelligence works the same as it does now. But what it's getting is cloud as an additional tier. So beyond our memory, NVMe flash, and then SSD or HDD, we can use cloud as a layer beyond that. So you can configure policies to determine how much of your data you want to keep on-premise, how much you want in the cloud, and the system will automatically handle that data movement. And it doesn't just move the data on demand, but it also has a lot of intelligence. We'll do read ahead. So it'll characterize, it'll understand and look at how you're using your data, and then if needed, begin to read ahead and pre-stage data as well. And then the other use cases can be used for beyond archiving is also cloud bursting. So you can use this cloud volume where you have AWS as, I think of it as kind of a relief valve. So if you're, say, tight on budget and you want to deploy a minimum amount of on-premise infrastructure and you run some risk that your data grows faster than you thought, then you can easily extend that off into the cloud until you've got time to add more nodes and re-optimize your system. So to wrap this up, we talked about how HCI has transformed the delivery of IT, and then we talked about how to extend that to private cloud. We have to be able to have some intelligence and policy-based management to be able to handle multi-workload environments. And then talked about how now Pivot 3 has expanded that to the world of hybrid cloud, where we're now simplifying hybrid cloud and multi-cloud environments as well. So thank you. That's what I had to present for you today, and now we can take questions.
Thank you very much for that presentation. We do have a few questions for you. I just wanted to say I've always been impressed by the Pivot 3 platform, and I remember a number of years ago being in a room at Tech Field Day, and Pivot 3 announced their hyperconverged platform before it was called hyperconverged. So your comment about Pivot 3 being hyperconverged before hyperconverged was a word definitely resonates with me.
Yeah, thank you.
One of the things we have from the audience is there an ability to schedule quality of service settings so you can, I guess, to schedule quality of service settings? What I think I'm hearing is can they have, at this time of day, this workload is more important, and this time of day, this one's more important? Is it get that granular?
Yes, yeah, it absolutely does. So, you can set your service levels for each workload, but then as you said, you can schedule those so that they change. So for example, during your workday, you might have a set of applications that are mission critical, and then, other ones that are non-critical. But then when you get to other times of day or times of the quarter, right? Like you might have certain applications running at the end or the beginning of the quarter that become increased in criticality. And yeah, you can schedule when each of those workloads have different policies, and then once you set that up front, that can run automatically because as I said, the priority of the applications can definitely change with the calendar and change over time.
Perfect. Our next question is around, so it looks like egress fees. So when you're sending data to AWS and then getting it back, I would imagine that you're going to be looking at this same egress fees you'd look at for any other egress charges from AWS, correct? There's nothing special or different that's going to result in an increased fee from Pivot 3.
Right. Yeah. Those are a function of the AWS policies and what they charge. What we do is try to make it easy so that when you're configuring the systems and setting your policies, that make it easy for the user to be thoughtful around how the system's actually going to behave. So, for example, like with the cloud archiving example, that I showed, when you set that up, there are warnings and triggers in there so that the customer has some visibility into what they're doing. What we don't want to do is make it easy for a customer to configure a volume where they're going to have some thrashing back and forth of the data and incurring charges that they might not realize. The other thing that we're working on is integrating with some of the cost APIs from AWS and the other clouds, and over time we'll be making more and more of the cloud costing and what's going on the cloud side visible within the Pivot 3 interface so that you can get a much clearer and easy picture of what those charges are, because I think that's one of the problems some customers encounter with cloud today is it's very easy to rack up bills and you don't necessarily have visibility into that until it's too late.
Dan, thank you so much for your presentation. As I said, it's always great to see Pivot 3 and see what's happening with the company. Thank you.
Yeah, thank you.